Hello everyone, welcome back to Code for Teachers. This is Chapter 3, Section 4. We're going to do a lesson now, and we're going to use the game Rock, Paper, Scissors to demonstrate some of the concepts that we've explored briefly in this chapter. So we're going to reproduce the Rock, Paper, Scissors game, which we should all be familiar with, and we're going to be translating the rules of the game into code. This exercise, whether with rock, paper, scissors, or with any other game, is incredibly powerful to get students engaged in the logical thinking, the computational thinking necessary for good programming, but also for good critical thought generally. So games are a great model for approaching these ideas, and producing a playable game in a programming language is a fun exercise for students. Another important concept that we're going to be exploring is using the right data type for the job at hand. There's no right or wrong way necessarily to solve a problem in programming, but there are definitely more and less efficient ways of doing it, and there are also more or less elegant ways of doing it. And we want to achieve the most elegant and efficient code possible. And that's where the craft of programming comes in, and it's also where we can be critical about our own code and discover how to do things better after the first pass. So let's think for a moment about our program design. We have to ask the user for a choice of rock, paper, or scissors. We're going to check to make sure that the user gave us sane input, or hopefully we'll be able to do that, otherwise the game won't work. The computer then has to randomly choose rock, paper, or scissors, and then we have to compare those two, choose a winner, and then print out the result. Now, but wait, of those things that we just mentioned, there's one that we haven't explored at all. How do we do this random situation? We don't know how to do that yet. To do this, we need to import our first external Python module, the random module. Python has several modules besides its core library that you can find in the Python documentation. And the random module is going to give us several methods to do, well, random stuff. Anything that has to do with random or, in fact, pseudo-random numbers. In this case, we're going to be using random.choice, and that returns a random element from a given list. So let's take a look at the beginning of our lesson design before jumping into the code. What we want to have students do is describe and perhaps visually diagram the rules of rock, paper, scissors. What beats what beats what, and also describe the way that the turns go. We want students to see if they can identify, even in the way that they describe the game, the parts that are clearly translatable into code, the pieces that they already know how to do. And the really tricky part here is how we decide a winner. One way we could do it is take the player choice and the computer choice and do a simple if-else. But if you play that out logically, there are a lot of if-else and nested if-else statements that you're going to see there. Think of all the possible outcomes. The computer and the player both have three options. So combining those together, you have multiple outcomes. There may be a more elegant way of determining the winner because we know ahead of time a little bit of information, like the rules of the game. Okay, so let's start writing some code here. The first thing we need to do is import the random module. So we write import random. That's all you need to do to get the random module and have access to that random.choice method. The first thing we need to do is get the player choice. So we will say, just to start, player underscore choice equals input, choose rock, paper, or scissors. And then we need to get the computer choice. Well, let's see. We know that we want to use random.choice. We'll say computer choice equals random.choice. But inside of the parentheses for random.choice, we have to give it a list to choose from. Well, how might we do that? Potentially the right way to do this is to create a list of choices. So let's do that up at the top of our code. Choices equals, and then we'll do a list containing rock, paper, scissors. This might come in handy for us later as well. So we have choices equals rock, paper, and scissors, all strings separated by commas. Computer choice equals random.choice, and then we just put in the name of our list, which is choices. Let's see that just so much. So we're going to put a print statement here for player choice. And then we're going to put another print statement under here for computer choice. And that's going to let us see just our code working so far. Choose rock, paper, or scissors. I'll choose rock. And the computer chose scissors. So actually I beat the computer here, but the code doesn't know that yet because we haven't written any of the game rules in. Okay, I'm going to get rid of these print statements for right now. Now, at the moment, the only way we have to determine the winner would be something like this. If player choice equals rock, and then inside of that condition, we would have 3 other conditions for the computer choice. Coming back out, we have player choice equals paper, and then 3 more for the computer, and then for player choice equals scissors, 3 more for the computer. That's pretty nasty. There are better ways of doing this, and this is where dictionaries are going to come in. So what we're going to do is we have this choices list, but we're actually going to have another piece of information, another variable that we're going to use here, and that's going to be called beats. So beats is going to be a dictionary that maps what beats what in rock, paper, scissors. So beats equals, and then I'm going to use my curly braces. You could do this all in one line, but I prefer to do this on multiple lines so it's clean and clear. So the key will be rock, that'll be the first one. The value, what does rock beat? Well, rock beats scissors. Okay. Paper, well, what does paper beat? Paper beats rock. And then scissors. Scissors beats paper. So what we've done here is we've been able to use a dictionary to encode the rules of rock, paper, scissors into this nice dictionary. Why is this useful? Well, because the keys are strings here, I can actually quickly access those values. I can even show you this right now by running it. So let's choose rock, paper, scissors, rock. But because I still have this loaded into memory, just to show you that, let me type beats. You can see that I still have that dictionary loaded into memory. So if I say beats rock, return scissors, I have a really easy way of determining who won this matchup. So in this case, we're going to think about it in terms of the way that the player choice and the computer choice match up. The simplest possibility is that it's a tie. We both throw rock or something like that. So let's write that if statement. If player choice equals computer choice. We don't even need to use the rules here. We just know that that's a tie. Print, it's a tie. Okay, 2 other possibilities. The player won, the player lost. And this time we're going to use the beats dictionary to determine that. So if beats player choice equals computer choice. So in other words, whatever this string is, whatever the player choice string is, if that's a key in the beats dictionary and the resulting value from accessing that key ends up matching the computer's choice, well then I've won because, so if my choice was rock, beats rock refers to scissors. If the computer's choice was scissors, I've won. So I'll say print, you win. Because there's only one other possibility, meaning that the beats computer choice equals my choice, I lost, I can just say else, print, you lose. All right. Now, I am going to put the print statement back up here for the computer's choice, just so it's a little bit easier to see what's going on. So I will say print, and then I'll do a string concatenation, another skill we know. Computer chose, plus computer choice. Okay, so let's run this. So I'll choose paper this time. Computer chose rock, and paper beats rock, and I win. Awesome. Let's run it one more time just to make sure everything's good. Let's try scissors. Computer chose paper, I win. Nice work. So that's actually a better win record than I usually have against the computer. Now, this isn't completely finished. I have some work that I need to do. The first thing to consider is that I can give the computer nonsense as my choice, right? So rock, paper, scissors, I will put in just a bunch of J's, and I get an error. That is not great. I do not want to have my game error out. So I have a couple of ways that I can fix this problem. Probably the easiest way to do it is to wrap all of my game code inside of a conditional. So I'm going to say if player choice in choices, then we're going to do all of this. So to make that happen, I'm going to indent all of this stuff because it's going to go all inside this conditional statement. And then I'm going to have this other conditional statement, else print not a valid choice. So let's take a look at this structure very carefully. I have this big if statement that just checks to make sure that the player choice was in fact in the list of choices. If so, I go through the trouble of actually running the game. Otherwise, I print not a valid choice and the program ends. So let's try this again. Not a valid choice, program ends. This is not the most elegant way to do this, but it's the simplest to implement for the moment. There may be other ways that your students can discover later. So in fact, let's talk about how we can extend this program. Can we extend the rules? We've written this dictionary with keys and values connected to each other for the game. So can we extend it to include other objects besides rocks, paper, and scissors? And can we do so while keeping the game balanced? What does adding one other object do versus adding 2 or 3? Could we use a loop to keep the game running more than once? Maybe we could also have some variables to keep track of score. And using the same structure, could students create their own games? Given this framework, there are a lot of things we can do with the code to make it more efficient. If you look at our GitHub repository, I'll put in some of the more refined versions of the rock, paper, scissors game, but what we have here on Replit is a great way to get started. All right, that's it for our very fast introduction to lists and dictionaries, our most common iterable data types, along with strings. And that concludes Chapter 3. In Chapter 4, we're going to tackle my favorite part of our introduction to programming, functions. I'm Michael Taggart. Thank you for watching Code for Teachers.